When you think about construction sites, you probably picture, well, grit, hard hats, maybe some massive machines, right? All very manual.
Absolutely. Lots of heavy lifting, tough conditions.
But what if those big machines started becoming autonomous, not just operating near people, but actually working with them as part of the team?
That's exactly the future the FORTIS EU project is aiming for. And it's a really fascinating development we're diving into today.
Right. So our mission is to unpack this FORTIS pilot. How are they trying to integrate these heavy-duty autonomous robots into construction? And especially, how does that human-robot collaboration piece actually work?
We'll look at the challenges, the tech involved, and what it signals for the future of building itself.
Yeah, I think you listening might have some real aha moments here, seeing how technology is changing even these, well, very traditional industries, making things safer, more efficient.
Definitely.
So let's start with the basics. Why construction and why now?
Well, construction has often lagged a bit, technologically speaking, compared to, say, manufacturing. But it seems like we're hitting a tipping point, maybe what some are calling construction 5.0.
Construction 5.0, okay.
And the crucial thing here really is that it's not about replacing the human workers. The main goal is augmentation.
Augmentation,
meaning boosting your capabilities, reducing the physical toll, the back-breaking stuff, and making the sites genuinely safer by mitigating risks. It's about humans plus machines.
Empowering them, not displacing them. I like that. Okay, so how does FORTIS actually plan to achieve this human-machine team-up?
So FORTIS kicked off in January 2024. It's a 4-year project. And its whole focus is integrating autonomous systems into these really challenging spots, like active construction sites.
Right, unpredictable environments.
Exactly. And they've structured their approach around 3 key goals. They call them tangible expected outcomes, or TEOs. Think of them as the building blocks for making this work.
Okay, TEOs, let's break them down. What's the first one? TEO 1. You said human-centric toolkit.
Yes, TEO 1. It's about deeply understanding and modeling human behavior, not just tracking movements, but learning individual work styles, maybe anticipating needs, even picking up on signs of fatigue through wearables.
So the robot adapts to the specific person it's working with. That sounds advanced.
It's moving towards a truly adaptive partnership beyond just basic commands, understanding the individual.
Okay, so the system understands the human side. What about the robots themselves? That must be TEO 2.
Spot on. TEO 2 is the FORTIS robot-centric toolkit. This is where they focus on the machines, crafting multi-robot setups, and importantly, retrofitting existing heavy equipment.
Retrofitting, so taking a standard machine like a Bobcat?
Exactly, like a Bobcat T190 compact loader or a Manitou telehandler, and essentially giving it an AI brain, advanced sensors, the works, turning it into an autonomous collaborator.
Got it. Human model robot tech. What's TEO 3, the HRI toolkit? How does that fit in?
Yeah. TEO 3 kind of brings it all together. The human-robot interaction, or HRI, toolkit. This uses tools to monitor, simulate, and really optimize how humans and robots work together. And this is where things like digital twins come in.
Ah, digital twins. We hear that term a lot. So like a virtual replica of the site.
Precisely. A dynamic virtual copy. They can run simulations, test interactions, iron out kinks, and optimize workflows, all in a safe virtual space before deploying it on the real site. It's the glue ensuring safety and efficiency.
That sounds incredibly thorough. How are they testing all this in the real world, though? I mean, construction sites aren't labs?
No, they definitely aren't. That's why they've set up a dedicated pilot site at Engenharia's headquarters in Portugal. It's about 1,000 square meters, outdoors, L-shaped.
And designed to be realistic.
Oh, yeah. Dust, debris, uneven ground, all the typical challenges are replicated there. It's a proper proving ground.
And I read it's kitted out with tech, too, right? CCTV, Wi-Fi, UWB positioning.
Yes. Ultra-wideband for really precise tracking of everything. People and machines. Plus, there's a special FORTIS tower structure for practicing specific assembly tasks.
Okay, so what are these robots actually doing on this test site? What are the key use cases?
2 main ones they're focusing on initially. First, material transportation. This uses that retrofitted autonomous Bobcat T190.
Just moving stuff around the site autonomously?
Basically, yeah. Optimizing the logistics, taking that repetitive, often strenuous task off human workers' plates. Reduces burden, frees them up for other things.
Makes sense. Less grunt work, fewer chances for minor accidents moving materials. And the second use case?
That's the sandwich panel assembly. This uses a bigger machine, a retrofitted Manitou MRT 2260 telehandler. And here, it's working very closely with human collaborators.
Installing building components,
Yeah.
like walls or panels.
Exactly. Lifting and positioning these large panels, which requires precision and, crucially, close coordination with the human workers guiding them. This is where that HRI really comes into play.
Right, communication must be absolutely critical there, and probably tricky on a noisy site.
Hugely important. FORTIS puts a big emphasis on seamless, safe interaction. For verbal communication, even with all the noise, they're prioritizing advanced audio gear to ensure clear commands and feedback.
But it's not just talking, is it? What about nonverbal cues?
You're right. Nonverbal is massive. Remember Morabian's rule. Words are only a small part. Tone and body language are huge.
73855, yeah.
So FORTIS uses advanced AI things like LSTM networks, transformer models, the kind of tech in modern language processing,
Okay.
to interpret human kinematic data body movements and even physiological signals from wearables.
So the robot can read body language, essentially, and maybe stress levels from
I
wearables.
was trying to interpret those signals, yes. And in turn, the robots use things like colored LED lights, visual signals, to communicate their status, intentions, or potential hazards clearly back to the humans.
A two-way street. And you mentioned a following interaction.
Yes, in the panel assembly. It's a form of coordinated physical collaboration, but without direct physical contact for safety. The telehandler does the heavy lift, follows the human worker's guidance for precise placement. It's real synergy.
Wow. Okay, so wrapping this up, the FORTIS project sounds like a really ambitious but practical step towards integrating robotics into construction.
It really is. It's tackling significant challenges head-on, aiming to boost safety and efficiency, not by replacing people, but by genuinely blending human skills with machine capabilities. It's about amplifying potential.
So it makes you think, doesn't it? What does this mean for how we even perceive teamwork down the line? If your teammate is an autonomous machine that understands your gestures, maybe even your fatigue levels, how does that change the nature of work itself in the next decade?
That's the big question, isn't it? It could redefine collaboration in ways we're only just beginning to imagine.